Hey students, this video is going to be for the last two sections. The final section of the guide there's no exercises with it, it's just a little bit of extra information for you. So I'm going to tack that onto the end of this video, which is mostly about constructors. I'm recording this on February 24th, which was Pink Shirt Day against harassment and bullying. So that's why I'm wearing this getup here. The shirt underneath is a Mohawk Student Association shirt that was produced a few years ago, specifically focusing on anti-LGBTQ bullying and harassment. Let's talk about constructors and inheritance. We left this to this point because constructors behave differently. So when you have a method, you know that method is going to get inherited if you extend the class. So foobar grandma here in this UML diagram is going to sort of pass down its x variable to foobar mama, which is going to in turn pass down its x and its y variable to foobar. So if I create an instance of type foobar down here in this weird little hierarchy, it'll have three variables in it, z, y, and x, and it'll have, in this case, 3 copies of toString. So each class is overriding toString, but the copies are all there, and we can call them with the super keyword, as I talked about in the last video. But we also have constructors here. And the weird thing about constructors is that they're not inherited. Okay, so foobar mama, the constructor, does not get passed down to foobar. And that kind of makes sense if you think about it, because the constructor is supposed to have the same name as the class. So we can't really inherit this one. It kind of has to stay stuck to this class. Same thing with foobar grandma here. Now notice each class has 2 overloaded constructors. We have a no argument one, which I'll call no arg. So arguments are the values that you pass. So if I call, for example, the foobar constructor here with 3 parameters, I have to pass 3 arguments to it. That's the difference between an argument and a parameter, is that the parameters are what are defined here. X, Y, and Z are the parameters. When I call the constructor, what I pass to it are actually arguments. So that's kind of the technical terminology for it. So each one has a multiple argument constructor. So this one, foobar mama, has one to set x and y, because it has y locally here and x comes from up here. Foobar grandma has one just to set x, and foobar has one to set all 3. And they each also have a no arg, or no argument constructor. So if we take a look at the code over here, here they are. Here's foobar grandma. This is just purely toy code. It's just here to show you what happens when we create objects of different types. So basically all the constructors are doing at the moment is they're just notifying you that they got called. So they're identifying themselves with the class name and the number of arguments. And if there's a variable there, it's assigning it if it can. So foobar mama collects an x and a y, but foobar mama can only assign y. We'll fix that later on. And it has a no arg and a 2 arg constructor, and foobar has a no arg and a 3 arg. Oops, that should say 3 arg. Let's fix that. I'll try and fix that in the code before you guys see this. It has a 3 arg constructor. This is from the sample code. And it's only setting z, but it does take x and y. And then foobar test over here, it does 2 things. It creates a new foobar object, and then it creates it with the no argument constructor, and then with the 3 argument constructor. So if we take a look at this, if we let it run, let's just take a look at the first part of the output here. So what's happened here is, like I said, there's 2 principles here. The first principle is that constructors are not inherited, number 1. Number 2, when you create an object, there will be a constructor called for every object, every class in the inheritance hierarchy. Okay, so we called the foobar constructor the no argument constructor, and as you can see, something called the foobar mama constructor and the foobar grandma constructor, and they appear to have done their work first. So it seems like we came down the hierarchy list from the top. Foobar grandma got executed first, then foobar mama, then foobar. So again, if we look at the hierarchy over here, it seems like this one went first, then this one, then this one. Now if we call the 3 argument constructor, you can see that the foobar 3 arg constructor did get called, And oh yeah, notice I print out the object that's created here. So since I called the noarg constructor, x, y, and z all have the same 0 value. But here where I called the 3arg constructor, z did get assigned. Over here in foobar, it does assign z, but it doesn't assign y and x. And the system saw fit to call the no argument constructors for foobar grandma and foobar mama. Okay, so that's what's going on. Now let's go back and take a look at the notes here. So two principles. Constructors are not inherited. One constructor will be called for every class in the inheritance hierarchy. By default, Java calls the constructor you ask for. So when we asked for the 3-argument foobar constructor, it called that one, and then it called the noarg constructor for everything in the superclass hierarchy. Okay. And yeah, the y and the z values aren't getting set properly, but we're going to resolve that. Okay, so here's a question. Here's a quick exercise, something for you guys to try. What will happen if you remove the no argument constructor from either foobar mama or foobar grandma? So just think about that for a second. So right now what's happening is when we call this constructor, it seems to automatically be calling foobar mama and foobar grandma. What's going to happen if we pull the rug out, if we remove one of those? So I'll let you think about that for a minute. You can even pause and try it on your own to see what happens before I do it. Okay, so let's go over here and go to foobar grandma. We're just going to comment this out. Control/ will auto comment something out for you. We're getting syntax errors. We have a syntax error here saying there is no default constructor available up above. And we should also see a syntax error. No? Oh yeah, no, this one's okay, right. This one's okay because I am able to call, this foobar is able to call the no argument constructor above in foobar mama, which is this one right here. It's foobar mama that has the problem because it can't call the no argument constructor above it. Okay, if we put that back, then the error goes away. And if we take out this one, then what we'll see is errors in foobar. So it seems like it's the constructor itself that wants to call the constructor up above. And that is in fact what's happening. What's happening is when I create foobar using this constructor, it calls this constructor first, but before it does this, it makes a call to the foobar mama no argument constructor. And that one, before it does anything, makes a call to the foobar grandma constructor. So that's why they seem to happen in the reverse order. So if I take out, let's go back to foobar mama. If I take this out, I get an error down here because I no longer have a no arg constructor. What's going to happen if I also take this one out? What happens if I take this one out as well? So think about that for a moment. This is a tricky one. This one goes deep. This is a deep inside baseball kind of thing. If I take this one out, the syntax error goes away. Now, to understand this, you're going to have to remember that when we don't specify any constructor at all, the system, that Java fills in a no argument constructor for us that does nothing. It's only when I define a constructor like this that the system stops adding automatically that no argument constructor for us. So if I have a constructor that's not a no argument constructor and I want to use a no argument constructor, I have to create it myself. So this will actually work now. If I run the foobar test, though, we won't see any output for foobar mama because it's calling the sort of phantom in the background no argument constructor that it adds, the Java system adds. So it's added its own no argument constructor here, and it's calling it, and then that one in turn calls the foobar grandma constructor. Okay, let's put all this stuff back here. Hang on, there we go. Let's go back and see where we're at in the handout. Okay, so we just did the quick exercise here. Now we want to talk about the super keyword. So we've already seen the super keyword, and we've seen that we can use it to access stuff from up above, stuff that we don't. So if we have a method that is overridden, we can use the super keyword to call the one up above. And the super and the this keyword are kind of similar in the sense that you can also use the this keyword to call another constructor. Well, similarly, you can also use the super keyword to call a constructor. So for example, if I wanted to add default values to, wait, let's do it in foobar. To foobar, I could say this, you know, -1, -1, -1. So now if I attempt to create a foobar object with no parameters here, it passes on the work of doing that to this constructor here. So this calls the other constructor with these parameters, -1, -1, -1. And if you remember that if we're going to do that, it can only be done in a constructor, and it can only be done as the first line of the constructor. So that's what this does. Okay, so that's kind of a review of what we've seen before. And if I run this, Control-Shift-F10, you will see a bit of a difference. Nope, not Control-Shift-F10. Here we go, run it right here. So we see what's happening here is we called, so this is the first one here where we created the foobar object like that. So we called this constructor. It passed on that call to this constructor before it did anything. So the first thing that we see is, yeah, okay. It's complicated. So the foobar constructor passed on its call to here. This constructor magically passed on its call up to foobar mama, the noarg constructor, which magically passed its call up to foobar grandma. So we see this one happening first, then this constructor returns and comes back to here, and this one happens, and then this one returns, comes back to here, and this one happens. So we set z to -1, and then finally this one returns back to here, and we get this line here. So they kind of seem to be happening in the reverse order, because each constructor is immediately calling another constructor before it does the actual work that it's going to do. So that's what happens when you use the this keyword. The super keyword can be used in the same way. So what we can do here is we can say what the system is actually doing is this. Even though we don't see it, it puts this line at the beginning of every, so I'm going to put it in there explicitly, every constructor that we write. If we don't specify a first line with a call to this or to super, the system automatically puts this line in for us, whether it's there or not. So that's what's happening is the super keyword works like the this keyword. It calls another constructor, but it calls a constructor from a level above. So foobar, this is now, I put it in explicitly, and you'll see it'll behave in exactly the same way when I run this. We'll see the exact same behavior here. I'm just making explicit what the system was already doing. So we call foobar, it calls this constructor, which calls the super constructor here, which calls the super constructor here, which calls the one above it, which we'll talk about in a moment, and then prints out its line. So that's the first line we get. This one returns back to here, which causes this line to be printed out, and then this, and it returns back to here, which causes this to happen, and then this one returns back to here, which causes this one to happen. Okay. You can call the constructors up above. And there's a general golden rule here, which is that a constructor should only set the variables at its level. And we're going to make them all private anyway, which means that we can only set z here. We can't set x here. If we try to do that, we'll get an error that x has private access. So what we actually want to do is we're collecting all the variables to initialize this object. We can set z here, but we're going to have to pass the x and y call up to the constructor above. So having done this, now I'm no longer calling the no argument constructor here. Now I'm calling this one, and I'm passing y to it. So you can see z got set to -1 here. We should see y getting set to -1 as well now that I've done that. So there you go. So now y is being set. So we call the no argument constructor. It says, okay, call this big constructor with 3 -1s. We set z to -1 here. We call the super constructor, which sets y to -1 here. But we're not calling the correct constructor up above here. We want to pass x on. That will call now this constructor here. Let's get rid of these because we don't need these. So now this is going to cause a chain to happen, which will cause us to set all 3 of the variables. Okay. So when I run this now, so here I called foobar with nothing. It passed the call on to the 3arg constructor, which passed the call to the 2arg and to the 1arg, and you can see each one set its own variables. And same thing happened when I created foobar with the values 1, 2, 3. It called the 3arg constructor, which called the 2arg above, which called the 1arg above, and they're all setting the variables that need to be set. Okay, the toString for foobar here is using the super keyword to call the toString up above. So foobar shows you what it can show you, and then it calls the toString up above, foobar mama, which shows you what it can show you, which is y, and then calls the toString up above, which is foobar grandma, which shows you the x. So that's why we're getting this sort of chain of toStrings here. Okay, so again, I left constructors to the end because it is complicated. But the take-home lesson of all this is that when you're inheriting one class from another, you use the constructors in the same way that you normally would. So I have one variable here that I'm allowed to set. So if we just look here, but I have 3 total variables inside the object because I'm inheriting an x and I'm inheriting a y. So you have to provide a constructor that lets the user set all of those variables that are in the inherited ones and the ones that exist in this class. You set the ones that you can, and then you use a call to super to pass on the work of setting the superclass variables to the superclass. So that calls this constructor here, which is able to set y, because y is defined here. And then it makes us a call to this correct superconstructor up here to set x. That's how we get everything set. And if you do not specify which superconstructor you want to call, the system fills in this. So it will, unless you say what superconstructor you want to call, the system will call the no argument constructor by default. Okay, so that is the situation of constructors. It's hard to explain and hard to see what's going on. Bring questions to the live class and feel free to rewatch this video. You'll get used to it. It's one of those things that you'll get used to. A constructor is basically just setting initial values for variables. So you set the ones you can at the level you're at, and then you pass on the rest up above. So things to remember are foobar here has 3 variables in it, x, y, and z, which means it needs a constructor to set them all, x, y, and z, but it can only set z itself. So it has to use the super keyword to get x and y set by foobar mama and by foobar grandma. Okay, I hope that went okay for you. It's a little bit hard to explain. Like I said, I feel a bit of struggle explaining to you, and I'm sure that you feel a little bit of struggle understanding it. But hopefully we've at least gotten some of the way there, and you can bring questions you have to the class. Now there are some exercises for this, and I'm going to suggest that you do A and B. So the geometric object classes, I believe, don't have any constructors right now. Let me just check that. So geometric object here, has no constructor. I just have setters and getters. So there's no constructor in geometric object, and you can see there's 5 different variables that you could set here. Circle also has no constructor. Because it extends geometric object, it gets those 5 variables plus it gets this extra one, radius. So what we need here is a constructor that can set all 6 variables, but you're only going to be able to actually assign radius here. You're going to have to use a call to super to call the geometric object constructor, which you'll also have to write here, which will set the rest of the 5 variables. And similarly for rectangle, it has everything that's in geometric object, plus it has these 2 extra variables. So what I'm asking you to do in this exercise is to add one constructor per class to set all the instance variable values, use the super keyword to call the superclass constructors, and then you'll have to change the draw class to test those constructors. So I would like you to use the draw class to pass all of those values on and make sure that everything works properly. And then part B is to add a second constructor to every geometric object class. So this means circle, rectangle, geometric object. Plus, if you did the previous exercises, it also means square and target. Add those to allow the user to create an object without specifying its location or line width. So it should have all the other variables, but not location or line width. and then fill in default values, 100 for X and Y and 10 for line width. And I want you to try and figure out a way to use both super and this to minimize code duplication. So within an object, within a class, you should use this to pass on one constructor call to a different constructor, and then you should use super effectively as well to pass the constructor chain up the line. And we'll review this in the live class. Okay, if you want to stop here, this would be a good point to go and do those exercises, but I am going to go on in this video and just talk about the object class. Okay, something that you may have noticed, whoops, here we are, close other tabs. Let's take a look at the Java FX API, which is the API that we were looking at before. Here we are. Any class we go to, we were looking at the label class before from the graphical user interfaces. It's got a long inheritance hierarchy, but at the top is object. And it actually doesn't really matter. Let's do stage. That's one of the classes that's used. So this has a different inheritance hierarchy, but then object is at the top again. If we go to Java 15 API, just the regular Java one, not the FX one, we could search here, for example, for the string class, which we've used before. There's object at the top again. Notice string doesn't inherit from anything but object. And if let's do scanner as well. How about that? So we've used scanners a lot. Same thing. Doesn't inherit from anything, but it does inherit from object. This class object is always at the top, even for your own classes. So if you create your own classes and then create JavaDoc documentation for them, in fact, let's do that now. Tools, generate JavaDoc. I don't have a lot of documentation in here. It's not that well documented, but let's put it on the desktop. Okay. That's good. Oh, might want to let me do it. C, users, Sam, desktop. Okay. /doc. There we go. I'm gonna say, give me everything. Give me all the tags as well. Okay, go. So it's going to generate, it's doing it down here, a bunch of JavaDoc pages for these classes. So here it is, it's opened it for me in the browser. If I go into week 8 code, I can pick any class here. Let's try foobar. So we can see here how it's generated it for me. It's telling me foobar inherits from foobar mama, which inherits from foobar grandma. Oh, and there's object at the top again. So even your own classes, any class that you define, if you don't have an extends line, so here I say rectangle extends geometric object. Geometric object doesn't have an extends. By default, it extends this generic class object. Okay, so object is always at the top. If we go back to the documentation that I just created here, let's search for geometric object. There it is. Again, it's at the top. Geometric object. And you can see, I think we should say known subclasses down here somewhere. Maybe not. Sometimes you get, oh, there we go, direct known subclasses. That's kind of cool. You can click rectangle and you can see rectangle inherits from geometric object, which inherits from object. So every class that you create, every class in the system has this mysterious object class at the top. And if we click on it, which we can click on it here in the official documentation, you'll see it just contains a single default constructor. So that one's always getting called every time we create a new object. And it's just got a few methods in it. And there's a couple that we've seen before. It has a toString method and it has an equals method. So every object you create, you are inheriting these things. So I can go rectangle.equals another rectangle or rectangle.toString. And if I haven't overridden the equals method or the toString method, it will call the one that's an object. So all those times earlier on in the course where we create, here, let me create a new Java class here, test, call it test object. Okay, and I'll just create a main method over here. Test object main right here. So PSVM, there we go. Test object T equals new test object. And then I go system out println T. So if you remember this, what this is going to do is print a little generic output string. How is it doing that? Well, it's doing that by calling the toString method that is defined in the object class. So I can explicitly call it here as well. The println statement accepts an object of any type and then calls its toString method, and it knows that every object will always have a toString method because every object in the system is of type object, has inherited from object. Okay, so there's no real exercises for this or anything like that. It's just something that I wanted to point out to you, which is the object class is always at the top. So every object you create, every class you create is inheriting things like the equals method and the toString method, and you can call them whether you override them or not. So that's why whenever we create a toString method, automatically IntelliJ always adds an override tag to it. Let's go to rectangle here. If we look at, see, this was generated automatically, I think, by the system, and it adds this @override tag to it. What is it overriding? It's overriding the toString that exists in the object class. Oh, actually, this one's probably overriding the geometric object toString, but this one is overriding the one from up above, the object class. Okay, and actually, we could do something cool like this. We could go right here. We could go super.toString plus that. Let's do that. That's kind of fun. And then we'll go to the draw method, and we'll print out. This is something I didn't think of doing until just now, so let's see what it looks like. Oh yeah, that's not going to work because they're not calling the geometric object. Well, okay, let's go into rectangle then, and we'll call. Let's just. This isn't very elegant, but super.toString like that. Get rid of this. It's not going to look great, but let's take a look at it. So the rectangle now will come out differently. So the rectangle is calling, so here's the output that came from the rectangle toString, and then it called the geometric object toString, which printed out before it printed that, and then that's where this is coming from, the x equals and the y equals, and that one made a call to its superclass's toString, which is the object toString, and that's what's printing out this, the type and the location. So that's how things like that's how you're able to just print any object. The system just calls its toString, which it knows is going to be there because you always inherit from the object method. Okay, so you can read over that section. There's a few other things. It talks a little bit about the equals method as well, and the role that it plays. You'll learn a lot more about that in your 4th semester data structures course. But that's it for this. So please do try those exercises, and I will see you in class.